Welcome to the first of our multi-part tutorial on ROADMs. In March of 2010, Arrigo published a research report entitled Another Optical Cycle is Brewing. In that report, we highlighted several technologies that we thought would be important in the coming optical cycle. But in this tutorial, we shall focus our efforts on describing only one of these technologies, ROADMs, or Reconfigurable Optical Add-Drop Multiplexers. In the middle of this diagram, we show examples of 4 companies that make ROADM systems, and on the right are 5 of the largest ROADM component suppliers in the world.
ROADM technology has been around for a while, but only recently, after there have been several bottlenecks in the network, have their deployments begun to take off. Although ROADMs can help increase bandwidth for a carrier, it is important for investors to understand that the primary reason that they are deployed is to help reduce the carrier's costs when managing bandwidth. Lastly, we will describe what wavelength selective switches are, as they are the key component inside of a ROADM. Although the two terms are often used interchangeably, the differences between a ROADM and a wavelength selective switch are important for investors to understand.
In this, the first of our multi-part tutorial on ROADMs, we will describe the issues that led to the development of ROADMs and why they've suddenly taken off in the network after being around for several years. In later parts of the tutorial, we will describe how ROADMs are made, the differences in technology between various ROADM vendors, and also future directions for ROADMs. Although ROADM technology has been around for a while, it was only after the advent of Verizon's Fios network and AT&T's UVerse network that ROADM technology began to be very popular in the United States. Shown here is a Verizon Fios network. AT&T's UVerse is similar. The amount of bandwidth that Fios required in the outside plant was an order of magnitude higher than what existed before. All these pieces of bandwidth began to increment the amount of bandwidth that was required on the metro portion and the long-haul portion of the network. Something had to be devised that could cost-effectively manage this bandwidth at the metro and long-haul levels without requiring changes from optical to electrical everywhere a piece of information needed to be extracted. ROADMs became ideally suited for this purpose.
Historically, optical add-drop multiplexers are used to extract and insert information into a fiber optic link. Here we see a telephone switch providing electrical signals into an add-drop multiplexer. The multiplexer then converts these signals to an optical stream. That optical stream is transmitted to the other end, where another optical add-drop multiplexer converts that signal back to an electrical level, where it can then be used by either data equipment or phone equipment. Historically, dense wave division multiplexing systems are used in conjunction with add-drop multiplexers to add multiple frequencies of light onto a single fiber and to extract information at the electrical level from these fibers. We see a fiber optic transmission line that has 4 such lambdas embedded within it. Today, when information needs to be extracted from a fiber, it typically passes through a SONET add-drop multiplexer. Inside this multiplexer, the optical signal is first converted to electrical. Those electrical signals are typically fed through some additional equipment such as a Cisco router, which extracts the information that's meant for local use. Afterwards, all the other information is put back through an electrical to optical interface and is sent back on the outgoing fiber. These optical to electrical conversions tend to be expensive. Note that no matter how many frequencies of light are traveling on this fiber, even if a small amount of information needs to be extracted, all the different frequencies need to be converted from optical to electrical in order to gain access to that precious few bits of information that are needed at the local node. It would be much more cost-effective if we could strip out an individual wavelength or light, or lambda, and only process that information if all the information needed locally were to be riding on that one frequency of light. A ROADM is just such a device. Let's talk a little bit about what ROADMs are. A ROADM is a blade that consists of 3 main components: a wavelength selective switch, a channel monitor, and an amplifier. The key component inside the ROADM is the wavelength selective switch. It is the main device that extracts a single frequency of light from a stream of multiple frequencies. With respect to the light, a wavelength selective switch is a passive device. It does not source light and it does not amplify light. When we talk about ROADMs, we often use the terms wavelength selective switch and ROADMs interchangeably, but in reality, the ROADM usually refers to the blade, which consists of all three of these components: the switch, the channel monitor or error detector, and the amplifier. These blades typically sit inside a transport or an optical switch. Shown here is the Sienna 4200 Metro Ethernet transport system. This is just one example of a system that can contain a ROADM blade. Let's review. ROADM technology has been around in the network for a while, but the recent use of FiOS has led to it taking off in volume. ROADMs consists of a wavelength selective switch, a channel monitor or error detector, and an amplifier. These three pieces fit together on a ROADM blade, which is then inserted in a ROADM system.